Ever wondered how a GPS finds the shortest route between a source and destination? They often use the breadth first search or BFS. It is the ultimate way to scan a hierarchy layer by layer in the world of trees. BFS is a level order traversal. Think of it like a scan where it explores every node at the current level before it is allowed to move on to the next level. To keep things organized, BFS relies on a queue data structures. Node is processed in the exact order they are discovered. They act as a waiting room for children of the parent while their parents are being visited. Let us understand how the algorithm moves. Add the root node to the queue, pull the front node and mark it as visited. Take all the children of that node and add them back to the queue. Repeat this process until the queue becomes empty. Let us understand this with an example. Let us consider the initial tree and a queue with empty. We add the root node to the queue and traverse over the queue while the queue becomes empty. The first element, which is 5, is popped out of the queue and its child 3 and 7 are enqueued into the queue. We either print the polled element or store it in an array as per the requirements of the question. Moving forward, 3 is polled out and its children 1 and 4 are enqueued into the queue along with 7. Moving forward, 7 is pulled out of the queue and its only child 8 is enqueued into the queue. 1, 4 and 8 are also respectively dequeued from the queue according to their order, and as they do not have any child, nothing is entered into the queue and the queue initially becomes empty. We use BFS because it is optimal for finding the shortest path in unweighted structure because we visit every node exactly once, and the space complexity is often in the worst case as the queue must store the widest level of trees, that is BF in the B of the BFS.